Hello dear students. So today we'll start with the few numericals. So first of all we'll consider a simple numerical of a simply supported beam with a center point load. The span of the beam is 4 meter and the load is acting at a 2 meter. Now as we already discussed, to calculate the reactions having a simple point load at the center, RA and RB is always equal to W by 2. Therefore, here we have calculated RA is equals to RB is equals to 20 by 2, that is 10 kilonewton. So, at the A, our reaction is 10 kilonewton. At B, our reaction is 10 kilonewton. Now, we will go towards the shear force calculation. So, what is our definition of shear force? Shear force means the algebraic sum of all the vertical forces either on the left side or on the right side. Suppose we will take the section in between A and C. So, first of all, we'll try to consider the left side. So, if we consider the left side, see there is only one force. What is our shear force rule? If we are considering the left side, upward is taken as positive, downward is taken as negative. And if we consider right side, upward is negative and downward is positive. So, first of all, we are taking the section between A and C and we'll be considering the left side. So, on the left side, there is only one force. So, shear force Fx will be equals to 10 kilonewton. Now, again, we'll consider the right side. There is no need to consider both the sides. As it is our first numerical, we'll consider both the sides and we will cross check. So, we'll consider right side. So, if we are calculating the shear force, considering the right side, see about this section on the right side, there are two forces. What is our sign convention? On right side, upward is negative, downward is positive. So, 20 kilonewton is downward, so we'll consider it as positive. RB is upward, so consider it as negative, so minus 10. So, again, Fx will be equals to 10 kilonewton. So, whether we consider left side or right side, the answer will be same. That's why either or you have to consider the side. Now we'll take the section between C and B. So we'll consider this section. So here also either consider right side or consider left side. So we'll consider right side as there is only one force. So if you consider the right side, Fx will be equals to. Now when we consider right side, upward is taken as negative and downward is taken as positive. So as we are considering the right side of the section and the force is going upward, on right side upward is negative, therefore Fx will be equals to 10 kilonewton. Understood? As we have considered the right side of the section. So here we can draw our shear force diagram as we obtained shear force diagram. So here on this section there is 10 kilonewton positive and in this section we have 10 kilonewton negative. Understood? Now we will move towards the bending moment calculations. Always take the sections to calculate bending moment at the support. Suppose we are taking the section at point C. So taking section at point C. So we are considering the section at point C. So rotate the forces either on the left side or on the right side. If suppose you are considering the left side, then clockwise is positive, anti-clockwise is negative. And if you are considering the right side, anti-clockwise is positive and clockwise is negative. So we will consider the forces on the left side of this section. Suppose we are considering at the left side, so we have to rotate this RA towards the C. If you are rotating RA towards the C, it is going clockwise, so it will be considered as positive and it will be the perpendicular distance will be 2 meter. So taking moment at C, so moment at C equals to, we will be considering the left side, rotate this force, this is clockwise, so positive. So 10 into the perpendicular distance is 2 meters, so 20 kilonewton meter will be your bending moment at point C. And as this is the simply support at simply support A and B, the moment will be always 0. So no need to calculate the moment at A and B. So directly we can draw the bending moment diagram. So the diagram will be like this. Here 10 kilonewton positive. At A and B there will be 0 moment. In this way we can calculate the shear force and bending moment of a simply supported beam with a center point load. Thank you.